In lesson 7.4, we're just looking at more multiplication properties of exponents. The difference is now we're not going to be looking at only like bases. Now we're looking at one base, and we're taking a power and raising it another power. So we're not combining like bases anymore. This is where it gets confusing with the rule from lesson 7.3 and the rule from lesson 7.4. You have to be able to realize there's no like base here. I'm not adding my exponents. What happens in these, if you were thinking about this in terms of what you know about math, this means whatever's in parentheses is going to be multiplied by itself 6 times. So I would end up with x to the third one, two, three, four, 5, 6 times. Now I have like bases. I'm at my rule from yesterday. I have all these x's multiplying. I have all these exponents with them. I can add up my exponents. 3, 6, 9, 12, 15, 18. Okay, or you can learn the rule that goes with it, which is, if you notice, 3 times 6 is also 18. This is when you get to basically distribute that exponent and multiply it to the other exponents in the parentheses. So, or you can use the rule, which is bring x over, and then it's 3 times 6, which ends up being x to the 18th. Same answer either way. The rule that you're going to add over here for that when I have a to the m to the n power, bring a and multiply m times n. So let's try a few of those. B, a to the 4th to the 7th. So again, you could write this out, a to the 4th times a to the 4th times a to the 4th times a to the 4th 7 times, or you can say a 4 times 7, and then a equals 20, or not equals, sorry, a to the 28th power. Let's try one more. A to the negative 4 to the 7th power. Okay, same rule applies. Don't worry about this negative. All this would mean is that a to the negative 4th would need to be multiplied 7 times, which would mean it would move to the denominator of a fraction. You still get a to the negative 4 times 7, which is a to the negative 28, but you're not allowed to write that way at the end, so your final simplified answer would say 1 over a to the 28th. Because you never want to write an answer with a negative exponent. And notice negative times a positive is a negative, which is what dropped it down to the bottom. If we'd written this the long way, it would have been 1 over a to the 4th times 1 over a to the 4th times 1 over a to the 4th times 1 over a to the 4th 7 times. Still would have ended up with 28 right here, power. Go ahead and add this to the left side of your notes and hit play when you're ready to continue. Just saying what we talked about here. When there's a base in parentheses like that, with an exponent on the outside, you're just going to multiply every base that you have in there, the exponent of every base, with the outside exponent. This is example 2. Example 2, you're going to do exactly what you learned to do here, but when you need to, you're also going to combine that with your like bases rule that we talked about in 7.3 to fully simplify when we need to. So this kind of follows an order of operation idea. We have this times this, but this is like a double exponent. And so exponents come before multiplication. You need to take care of that before you can multiply that. So So you would just bring c to the 5th down, times, now you use the rule you just learned, which is 3 times the negative 2, which becomes negative 6. Now you're at yesterday's rule, like bases. Once you're at like bases, bring the base down, 5 plus a negative 6, and that becomes a negative 1, and you never write your answers with a negative exponent, you just move them in the fraction to make them positive. Remember, I don't need first power once it's just a 1. So hopefully everyone saw I just did that. This was c to the 5th times this right here. I needed to simplify that first. 3 times the negative 2 is a negative 6. Now I have like bases, so I bring my base down and I add my exponents. Once I added my exponents, I had a negative exponent, so I apply the rule I learned from lesson 7.1, and now I have my final expression simplified. If you want to try this one, just try it on your own. If you want me to go through it, just keep watching. So again, this is what I need to deal with first, right there. I see multiplication, I see exponents to deal with. I'm going to always deal with those first. I know this has an exponent, but here I have an exponent multiplying right there. So now I bring down t squared times t, 7 times the negative 2 is a negative 14. Like base, so I can just bring my base over, and I have 2 plus a negative 14, which ends up being t to the negative 12, and I write my final expression 1 over t to the 12. Let's look at one more. A to the 4th squared times a squared to the 5th. So when you're looking at this, again, you want to kind of think about, okay, I need to deal with exponents here and exponents here before I can multiply these together. You're using the rule where you have one base and 2 exponents side by side outside of the parentheses there, which is the multiplication rule. I have a to the 4th times a to the 4th, or 4 times 2, which gives me a to the 8th times a to the same idea. Second 5 times is 10th. Now I have my like base rule. From there, I have a to the 8 plus 10, which is a to the 18th. Again, if you're ever getting confused on this, just write it the long way until you get that pattern down. A to the 4th times a to the 4th would be a to the 8th. A to the 2nd times 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 a to the 2nd would be a to the 10th. I have 18 a's altogether, multiplying to each other. In example 3, we're just continuing to use the same rule, but now we're just taking it a step further. We're adding something else to it. Notice here we have 2 times x to the 4th squared. Now you have to think about this in terms of, this is in parentheses, so squared goes to every base in there. So 2 squared, x to the 4th squared. You're going to have to square both of them. So one way to look at that would be 2 squared times x to the 4th squared, if you needed to split it up to see that. Okay, other people like to just draw an arrow to show it distributing in. You need to recognize that this is one term. You're only allowed to distribute in an exponent like we are right here when this is one term, when there's no addition or subtraction between it. Later in the year, you're going to start to see this with an addition or subtraction between it. We're going to have to do that a completely different way, so be aware of that now. And now you just simplify it using the rules you've learned. 2 squared is 4, and x to the 4th twice would be x to the 8th, and you're done. Same thing we've been doing, just more than one piece to that term. Write down what's on the left. It's what I just talked about. The exponent outside the parentheses needs to be distributed to each part of the term. And remember, this is like a 2 to the 1st power, so that rule still applies. 1 times 2 is 2. If this had been to the 0 power, 0 times 2 would have been 0. It still would have just been the number 1. Hit pause, hit play when you're ready to go on to this example. So again, we're just looking at this, each piece of the term. So we have 2 to the 4th power times z to the 4th power. 2 times 2, it's not 2 times 4. 2 times 2 times 2 times 2 is 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So you end up with 16. Z to the 1st power to the 4th power would be z to the 4th power. Let's look at one more of these. Write that down. If you want to, try it on your own. Otherwise, just follow along with me. So again, I see 4 times g to the 5th. So those are my 2 parts of one term there. So you have an option here. Like I said before, the negatives, sometimes those confuse you. So I'm going to show you both ways you could have done this. You have 4 to the negative 2 times g to the 5th to the negative 2, which ends up giving you 4 to the negative 2 times g to the negative 10. And now you would bring these down to be able to flip them around. So this would actually be 1 over 4 squared g to the 10th. And what is 4 times 4? It's 16. So you would end up with 1 over 16 g to the 10th. Okay, that's one way you could have done that. The other way you could have done that is just right off the bat, moved this whole set of parentheses down and made that negative exponent a positive. So you could have moved it down 1 over 4g to the 5th squared. Then you would have written it 1 over 4 squared times g to the 5th squared. And then it would have been 1 over 16g to the 10th. 4 squared, g to the 5th squared. Either way, you would have had the right answer. As we move into example 4, again, we're not changing any rules. All we're doing is adding more again. We're just adding more stuff to this. You've just been multiplying these out, and you've been multiplying these out. Now they're saying, okay, multiply this, and then combine it all together at the end. So just adding steps to things you've already been doing. My suggestion when you go to look at these would be to only look at one set of parentheses at a time. Once you have everything written out, then you start combining things that are like bases and adding them up together. So if I was solving this, I would look at this piece first, and I would say negative 2 times 2 is negative 4, so I have x to the negative 4, times, now I'm going to look at this piece individually. I have 3 to the 4th power times x to the 4th power times y squared to the 4th power. If you don't understand how I just got that, I took each product in this term, put it all to the 4th power. Now I'm going to simplify each of these. I'm just going to leave this, even though I know it's eventually going to move to the bottom of a fraction. I'm going to wait right now. X to the negative 4th times 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Don't make silly mistakes multiplying these out. Times 81 times x to the 1st power to the 4th power is just x to the 4th. Y squared 4 times is y to the eighth. Now from here, I'm going to start to look for things that I can combine. Again, you have two options. You can use the rule of adding your exponents here, or you can move this to the bottom of a fraction. So there's two ways that you could go about doing this and still end up at the right answer. So I'm going to go ahead and split it from here, and we'll show both ways. One way would have had 81 x to the fourth y to the eighth over this negative x to the fourth. Notice you have 4 x's and 4 x's, so all of them would cancel, and you would end up with 81y to the eighth. Okay, that's one option. Or you use the rules we've already learned about. This is actually the next lesson's rule that you're learning here if you're doing it this way. Or we say, okay, 81, because coefficients always come first. And then we have x, and we have 4 plus a negative 4, because we're adding our exponents. And then y to the eighth. And when we notice that, we get 81 x to the 0, y to the eighth. And you know anything to the 0 power becomes a 1. 81 times 1 is 81. So you still end up with 81y to the eighth. Two ways to get to the same solution there. Doesn't matter. Let's try another one. C squared cubed times 3c to the fifth to the fourth. And if you want to hit pause and try it on your own, go for it. Otherwise, you can just follow along with me. So again, I'm just going to look at this set of parentheses first, then this set, then I will combine them all at the end. So c squared 3 times is c to the sixth. Now I'm looking at each product in here. So I have 3 to the fourth and c to the fifth to the fourth. Notice as I'm distributing that exponent in, I'm dropping my parentheses. You always want to get rid of those eventually. So now I have c to the sixth times, again, 3 times 3 times 3 times 3, which ends up being 81, times c to the 5, and it's 5th power 4 times, so 5 times 4, which is 20. Now I have these like bases. Once I have those like bases, I can add those exponents. So I end up with 81 c to the 20 plus 6, which is 26, and that is simplified. Write what's on the left. Hit pause. When you're done, hit play. I'll move it up because there's a little more at the bottom there. But what I'm saying is, again, when you see more than one set of parentheses side by side there, simplify each one of them individually, like you've already learned how. Then you look for the like bases, and you simplify further. So hit pause, hit play when you're ready to finish that. And then once you've done that, just always remember that your final simplified expression should not have 0 or negative exponents in it, because you should have made any 0 exponents a 1, and you should have made any negative exponents move in the fraction so they became positive. Hit pause, hit play when you're ready to move on. Again, if you're feeling pretty good about this and you want to try it, hit pause and just try it on your own. If you're still feeling like you're a little bit unsure, just follow along with me and really pay attention to the patterns that you're seeing. The problem with these is that I could show you examples all day long because there's always a new variation of all these rules. And the best thing you can do is just practice it and get used to the basic rules and using them correctly. And that way, no matter which type of problem you see, negatives, zeros, anything in there, you always know what to do with it. So again, I'm just going to look at this first, and I end up with 2 to the 5th power times a cubed to the 5th power. Now I can look at this part, times 3 each of the products. There's 3 products in that one term there. 3 cubed times a cubed times b squared cubed. And now I'm just going to go through and simplify each part here individually. So 2 times 2 times 2 times 2 times 2. I have to stop and think about that number. So 2 times 2 is 4. Now what I notice, I'm just going to show on my fingers here so that you see what happens. To the 5th power, every year I get students who say 2 times 2 is 4. Times 2 is 8. It's not. That ends up giving you 6 of them in the end. You really need to think 2 times 2 is 4. There's your first 2. 4 times 2 is 8. 8 times 2 is 16. 16 times 2. Do you see how that works? So you only want 5. Don't accidentally get 6 there. And 16 times 2 should be 32. So that's the first one. Times a to the 3rd 5 times is going to be a to the 15th. Times 3 times 3 times 3. It's not 3 times 3. 3 times 3 is 9. 9 times 3 is 27. A to the 3rd power, because it's a to the 1st cubed. And then b squared, b squared, b squared is b to the 6th. Now from here I can look for things that are the same. So 32 times 27. On a test, you would actually have to go off to the side and multiply that out. In homework, I don't mind if you want to use a calculator. So 32 times 27 is 864. And now I see these a's that I have in common, like base. So I bring a over and I add them up. I have 15 and 3. I have 18 total. You've got to make sure you don't accidentally follow this rule where we multiplied. You need to know the difference between those. And then b to the 6th. Let's try one more. So there it is. Again, if you want to try it on your own, go for it. Otherwise, just follow along with me. So we're going to look at each set of parentheses individually. I have 3 parts, 3 products here in this term. So I'm going to distribute that cubed power 3 times. So 6 to the 3rd power times m to the 3rd power times n to the 3rd power. Some of you are going to get really good at this to the point where you don't have to show me each little piece here. But I'm showing it in the notes because I really want you to start looking for that difference there. Times, and now we have 5 squared on the outside, times m to the negative 3 squared on the outside. So now you're going to simplify each individually. 6 times 6 times 6. 6 times 6 is 36. 36 times 6, I just typed into my calculator, is 216. Times m cubed times n cubed times, remember it's not 5 times 2, 5 times 5. Such a common mistake, and it makes all this work not worthwhile if you're going to make that mistake there. Times m to the negative 6. So again, this is the one that jumps out at me as it's going to have to move, or I'm going to use that rule because I have these like exponents there. It's going to be up to you, or bases, sorry. So now I look, I notice I have 216 times 25. And again, I just type that into the calculator and end up with 5,400. Now it's up to you. how you're going to handle this, okay? For this example, since I've been doing it the other way, I'm going to go ahead and say m to the 3 plus negative 6, just so you get used to seeing it both ways. So that was the two m's, the like bases combined, and then now I have times n to the 3rd left over there. I need to simplify this further. I get 5,400 m to the negative 3, got to be really careful there, n to the 3rd. And I notice that I still have to deal with that because that's not fully simplified. That needs to move down to the bottom of a fraction. So I end up with 5,400 n cubed over m cubed, and it becomes a positive exponent. You're going to get a lot of practice with these all different ways so that you really get good at them. But again, you just need to make sure when you're seeing these positives and negatives, you're either using the correct rule or moving them down in the fractions or up if needed.